Unit 4, Calculus, Day 33-34 notes. Our objective for this lesson is to use the first and second derivative of a function to analytically determine intervals of increasing, decreasing, concave up and down, coordinates of relative extrema, and coordinates of points of inflection. You may remember we've already been talking about increasing, decreasing. We've quickly shown concave up and down, but we haven't used it in this aspect. All right, so let's jump right in. So what we're looking at, analytical and graphical connections between the original function, the first derivative, and the second derivative. So f of x, f prime of x, and f double prime of x. Let's begin by filling in the following charts about the relationships that exist between the graphs of the function and its first derivative. So if the first derivative is 0, or is also undefined at x equals a, then what do I know about the original function? Then I know that it's going to have a potential relative max or min. Because again, if the derivative, which means the slope of the tangent line, is 0, then that tells us there's a horizontal line. Okay, second one, what if I know the derivative is positive? Then that tells me the original function is increasing. We also knew that when the derivative is negative, I'm just going to write those two in there, positive, and this is when the derivative is negative, then I know the original function is decreasing. Okay, next, what if the derivative changes from positive to negative? So if the derivative was increasing, obviously then it's going to have to go to 0 and then change from positive to negative. So it's increasing then decreasing, then I know the original function has relative max. And I was drawing what the original function would be. So it has a relative max. Again, rewrote that. And I put up here, hey, here's all these tangent lines are going to be positive here. Get to that one, be 0, and then they'll start to decrease. Hey, what is my original function going to be? It's going to have a relative max. And the last one, obviously, if it changes from negative to positive, it's going to have a relative min. Okay, so let's look at that problem on the bottom of the page. And first, sorry that the writing's so small on this video. So we've already done a lot of this analysis. So you've already seen this in action with polynomial functions. For the polynomial function below, determine the interval where the graph is increasing, decreasing, has a relative max, and or has a relative min. Show your analysis and justify your answers. So the first thing we did was we found the derivative, and then we found where the derivative was equal to 0. So f prime of x, so we start with a polynomial function, use our power rule, 4x cubed, use our power rule, negative 12x squared. Okay, what's the derivative stand for? Slope of a tangent line. Well, let's see where that's 0, because then I can put it on a sign change chart and find out a little bit below it if it's positive or negative, a little bit above it whether it's positive or negative. So let's factor this and then we'll see what we get. So I first can take out a 4x and I'm left with x squared minus, excuse me, take out a 4x squared. Take out the x squared, and we're left with x minus 3 equal to 0. So I have two things multiplied together equals 0, so at least one of them must be 0. So either 4x squared equals 0, or x minus 3 equals 0. Over here, x will equal 0, and here, x will equal 3. So these are my critical values, critical numbers, and I'm going to label them on a number line that is dealing with the derivative. And we just said at 0 and at 3, I'm going to get a 0. So let's pick some numbers. A number a little bit less than 0 will be, hey, x equals, let's do negative 3, a little bit above 0 but less than 3 will be, I don't know, I can pick 1 or 2. I'll pick 1. And anything above 3, I'll pick 5. So now let's substitute these back in um, to what we factored out. So when I put in -3, -3 squared is positive, times 4 is positive, and then -3 minus 3 is negative. So I get a positive times a negative is going to be negative. Let's put 1 in here. Pick a different color here. So 1 squared is 1 times 4 is positive 4. 1 minus 3 is -2. So positive times a negative is negative again. And again, these were where my two zeros were. So nothing happened there. And then um, when x equals 5, 5 squared is positive times 4 is still positive. But then 5 minus 3 is positive. So this will be a positive. Again, so we're going down, and then we go back up. So let's answer some of the questions here. It says, where's the graph increasing and where's it decreasing? So let's write these down. Okay, so using our sign change chart, we found this information about the derivative, which we learned will, again, a couple units back, will tell us some information about the original function. So the original function is increasing on the interval from 3 to positive infinity. And again, why? Because the derivative is positive. Where's the function decreasing? Well, it's decreasing from negative infinity all the way to 0. And then we union that with 0 to 3, not including the 0 and the 3. And why is that true? That's because the derivative of the function is negative. Okay, then it asks, where does it have a relative max and or a relative min? Well, to have a relative max, it has to go positive, 0, negative. It doesn't do that. So it doesn't have a relative max, and then to have a relative min, it has to go negative, 0, and then positive. And it does have one at x equals 3. So let me just write that down. Okay, so we just wrote those out. So f of x does not have relative max because f prime of x never changes from positive to negative, and f of x has a relative min at x equals 3, which we found up there, because the derivative changes from negative, obviously it has to cross through 0, and then go to positive. Alright, that'll be part 1 of the video.